let's find sine, cosine, and tangent of angle A. Okay, so sine, cosine, and tangent of angle A. What is sine, cosine, and tangent? What are they? Josh? Just say one word. They are... Okay, wait. That's not what isn't Josh. Yeah, ratios. Okay, good. They're ratios. Okay, they're ratios that compare the sides in a right triangle. So I'm going to draw a right triangle, and we're going to relate it to last unit. Here's angle A, here's angle B, here's angle C. This angle right here is 60 degrees. And we're going to find the sine, cosine, and tangent of angle A. So, what's up, Sophia? What? You don't have to do those. These parts? Yeah. The way where the angle is located. Yeah, we'll come back to that. We'll come back and fill in that packet later on. All right. So, what is the sine ratio? Opposite what? Opposite hypotenuse. Okay, how did you remember that, Mr. What should I say? Doko? What? How about your first name? What? How'd you remember that? You just remember from yesterday? What's cosine? You remember that one? Oh, are you looking at your notes? What are you doing? Do you guys remember the, what's that little thing I put on that mnemonic device? What is that called when you like Holmes? Holmes. Homes. Huron, Ontario, Michigan, Erie, Superior. Like, what's that called? Like when you use those letters to remember something. An acronym? Okay, thank you. An acronym. What's the acronym for the trig ratio side? What? Sokolowski? Yeah, Sakatua. Kind of. That looks closer than sides. Kieran? All right, good. All right, yeah. So this acronym will help you remember what the ratios are. The sine ratio. This is like at the end of the period yesterday when everyone was like, oh, I'm going to pack up my bags because Mr. Sokolowski isn't going to say anything important for the rest of the period in the last 30 seconds, remember? But then I gave you this. Sine is the opposite to the hypotenuse ratio. Cosine is adjacent to hypotenuse ratio. Tangent is opposite over adjacent. Okay? So sine of angle A is the opposite to the hypotenuse. Opposite over hypotenuse. So here's the 30, 60, 90 triangle. What are the ratio of our sides? Kieran, you still have your hand up for the last 20 minutes. What's up? What? Yeah, I know, and I'm going to call on you.
BC over AB.
Okay, you're giving me side lengths. I want measurements.
Maybe 3x. I mean 3 wait. No. Yeah, wait. X and 3x rad 3.
3x rad 3. Okay, so you're starting to give me the ratios of a 30, 60, 90 triangle, right? Okay, let's just start with like the basic one. What's the smallest one? If this is, give me a value.
3.
Okay, write 3.
1.
How about 1? If that's 1, what's the hypotenuse? 2, what's this? 1 rad 3, or just rad 3. This is what we learned last unit, what the ratios of the sides of a 30, 60, 90 triangle are. If this was 4, this would be 8, and this would be 4 rad 3. If this was 10, this would be...
I'm at 20.
20, this would be 10 rad 3. If this was 11, this was 11. Okay, right? Remember those ratios? Okay? Now, let's write the sine ratio. Sine of angle A is the opposite side over the hypotenuse. What side is opposite angle A? Good, rad 3. So this is rad 3 over the hypotenuse, which is 2. Rad 3 over 2. That's the sine of angle A. Now, even if we had other measurements there, if this was 11, right? If this was 11, and this was 11 rad 3, and this was 22, we'd still get the same thing. If we did sine of angle A and these were our measurements, we'd have 11 rad 3 over 22. What's 11 over 22? 1/2. 1/2. You still get the same thing. You would just reduce the fraction. All right. What's the cosine of angle A?
1/2.
How about someone besides Karen giving me the answers every time? What's the adjacent side? The adjacent side's 1. The hypotenuse is 2. 1/2. What's the tangent of angle A? All right, good. Rad 3 over what?
1.
Yeah. Opposite over adjacent. Rad 3. Now you can write rad 3 over 1 or just rad 3. Okay? So we just found the sine, cosine, and tangent of angle A. Now you do the sine of angle B, the cosine of angle B, and the tangent of angle B. Give me sine, cosine, and tangent of angle B. So right now we're just writing the ratio. What's your problem? Why?
Swear to God, you got a different water bottle.
No, this is the one I brought today. What stinks about this water bottle? What's that thing called that's in there? The rubber flask thing? What's that called?
The filter?
Yeah, not the filter. The
Straw?
that O-ring thing that's in there. It's missing. So now it's like leaks. See, look, leaks. Now the floor is wet, and now when I walk around the room, it's going to make noises. All right. Let's go with Steven. What do you get for sine of B?
I got
1 over 2. Good. Sine of angle B. Here's angle B. The opposite side is 1. The hypotenuse is 2. Cosine of B, Kelsey. Rad 3 over 2. Bam. Nice. Rad 3 over 2. This is the adjacent. That's the hypotenuse. Adjacent hypotenuse. What about tangent, Sophia? No. Sophia, here's angle B. What side is opposite?
A.
That's an angle.
It looks opposite to me.
Amir, don't laugh at your friend.
I
Side.
don't know.
What side? These two sides are connected to angle B. These two sides are connected to angle B, so which one's opposite?
1.
That's 1. Which one's adjacent? This one or this one?
3.
Well, both of them are adjacent, but this is the hypotenuse. It's the side opposite the right angle. So if that's the hypotenuse, this one has to be adjacent side, so you get 1 over rad 3. Okay, thank you. Somebody's noticing a problem with our final answer. Side, what were you talking about? Can't have a radical in the denominator. So let's get rid of it. How do we get rid of it? Times rad 3 over rad 3. This was also things we did last unit. you get rad 3 over square root of 3 times the square root of 3 is the square root of 9, which is 3. Okay. Now, in this problem, I gave you the angle measure. I told you it was 60 degrees. Right? Now, if you didn't know this was 60 degrees and I just gave you the side lengths, based on what we learned last semester, we would know that that's 60 degrees. Because the only triangle that has a ratio of 1 to 2 and rad 3 of the sides is a 30, 60, 90 triangle. Now, if we didn't know that, the reason we have trig is so we could find that angle. Well, one of the reasons we have it is so we can find the measure of that angle. Remember, we started this at the end of the period yesterday. We used these trig ratios to find the angle measure. What did we use? We did trig on this device that has these buttons. What? The calculator. Remember, we punched that thing. Josh is holding up right there. We took out the calculator and we punched this stuff in. So let's use any of those trig ratios. Which one looks the easiest? 1 over 2. Yeah, that one's easy to punch in our calculator. So we're going to take this and to find the measure of angle A, we're going to do what? Do you remember how we ended the class yesterday? What did we punch in? Josh? You're going to hit second cosine. It's going to give you the inverse cosine, and then you're going to punch 1 divided by 2. So when you punch this in your calculator, the measure of angle A, what happens? What does it give you? 60 degrees. Well, we already knew that. Okay, but now the calculator is showing us and confirming that that's 60 degrees. Yesterday, we got some other angle measures. So one of the things that we're going to be doing with these trig ratios is using it to find a missing angle measure. Okay? So here we wrote the ratios, kind of showing you where one of the angles come from. Now I'm going to give you the side lengths, and we're going to use trig to find an angle measurement. Okay, any questions so far? And I'll show you how to use the calculators, those of you that were like, what are you talking about, in a minute. Okay, and you also have to make sure your calculator's in degree mode. Remember that? From yesterday? Okay, Mia, you weren't here yesterday, so what kind of calculator do you have? Yeah, okay, so let me see. You got to make sure it's in degree mode or it won't work. So, yeah, right there, see there, E, G, so you're good. And I'll show you in a minute. Let's try it first. So I'm going to give you, let's do the same thing. Let's find the measure of angle, let's use some different letters, D, okay? So here's our triangle. D, E, F. This side is 10, and this side is 16. And we want to find the measure of angle D. Why did I erase? Okay. Make sure you know how to spell it. Now, the first thing we need to do is figure out which trig ratio we're going to use. So it all goes with what angle we're trying to find. In relationship to this angle, what is this side that we know? We have an opposite side, we have an adjacent side, we have a hypotenuse. In relationship to this angle, what is the 10? Bill Gunn? That's the adjacent side. What is the 16? Sophia? No, opposite would mean it's not connected to it. So it's the hypotenuse. And look, and here's the right angle. It's the side opposite the right angle. So we have the adjacent side and we have the hypotenuse. Adjacent, right here. Adjacent hypotenuse is cosine. So we're going to write cosine of angle D equals, and now we're going to write the ratio. What's adjacent over hypotenuse? 10 over 16. So we write the angle, and then we write the ratio. Now, if we want to find the measure of angle D, we do what? Josh, this is the question you answered earlier. What are we doing? Okay, depending on your calculator, right? Most of the calculators that most of you have you're going to hit second cosine to get inverse cosine, and then do 10 divided by 16 in your calculator. All right, so those of you need help with your calculator, let me see. That's exactly what you're punching in, right there. What does that look like? What is this?
I don't know.
What kind of calculator is this? I've never seen one of these before. I don't even know how to get out of this screen. Okay, here we go. I actually did. Okay, clear. Okay, you're gonna hit second shift. You're gonna hit shift. Hit shift. That's not shift. That was alpha. OMG. Shift is the one that says shift. Oh my! Look at.
Bro, I'm gonna look
Shift.
at that box.
Cosine. Parentheses. 10 divided by 16. Punch it in. 10 divided by 16. Close the parentheses. Enter. Bam. Yeah.
Is it in degrees?
It is in degrees. Second. Cosine. 10 divided by 16. Enter. There's a 0.
Oh. I didn't do that.
Close the parentheses. Enter. There's your answer.
So, wait, what does this do? Like,
That gives you the angle measure.
Oh.
The angle of angle D is 51.3 degrees. 51.3. Okay? What's up, Haya? You need a calculator help too? Okay, hold on. Those of you that need help with the calculator, I'm going to put another problem up. Everybody try to solve, find the missing angle, and then I'll walk around and help some people with their calculator. All right? So number 2, or whatever number we're on, I don't even know. Is this number 1? Want to call this number 1? I don't care. However you guys are on number in your notes. For those of you that are taking notes, pretty good taking notes. All right. All right. Find the measure of angle D in there. Try to set it up. Find the measure of the angle. I'll help you out with your calculator. It's in degree mode. You got to get to here. So you're going to hit shift, cosine. Okay.
Oh, and then I just.
And then you just hit 10 divided by 16. Yeah. Who else
So
needs help?
which angle do we find?
We're finding the same thing. Same direction. Sorry. Find measure of angle D. Same directions.
I swear I'm getting a calculator tomorrow, but how do I do it on here? I don't know. But I'm getting a calculator tomorrow.
Oh,
Okay.
Clear this out of here. Hit second. No, yeah, hit second. See if that works. Hit second. There you go. Now hit cosine. No, actually you can't do it like that. On here, clear it out of here. You actually have to hit 10 divided by 16 first and hit enter. So do 10 divided by 16.
What? Oh.
10 divided by 16. Now hit the second. You already hit the second button. Now hit cosine. There you go.
Is that the angle?
Look, 51.3.
Oh.
41.4 second tangent. Yeah. Yep. What did you guys get? 41.4?
41.4.
41.4. Did you use tangent?
Yeah.
Did you hit second tangent? Second tangent?
Oh, I think I did.
That says cosine. You got it? Okay. Now, why did you guys use tangent? Bilgan, why did you use tangent?
Because the opposite of it.
Okay, right. In this problem, in relationship to angle D, which is the angle we're trying to find, you're given the opposite and you're given the adjacent. Opposite adjacent is tangent. So tangent of D equals 15 over 17. And then in your calculator, you're hitting inverse tangent 15 divided by 17. And what did we just say we got? Approximately 41.4 degrees. Okay. Now, how do you find the other angle? Okay, yeah, you could just add them up and they all have to add up to 180. Or we could do the same thing. Tangent of F equals 17 over 15. And now in our calculator, we would hit inverse tangent of 17 over 15. What's up, Sophia? Yeah? Oh, let me help you in a second, okay? Hold on, let me do something else. All right. Now, let me show you something else and how it's related to last unit. Actually, not yet. Not yet. Okay, so we just used this to find missing angles. We could also use it to find missing sides. Okay, and Sophia, I'll help you with that calculator in a second. I want to set up a problem first. Okay, so now we just found some angles. Oh, stop erasing that. Sorry. Okay. Now we're going to find, I'm just going to write X. We're going to find X is going to be the missing side. Okay, so on problem number 3, it says 35 degrees. Yep. Now, everything that we're doing is in relationship to an angle. That's how we set up the ratios, right? So when we're trying to find an angle measure, how are the sides related to that angle? Now we're given an angle measure. Still, how are the sides that we're trying to find and given related to that angle? So 35 degrees, X is the opposite, 14 is the hypotenuse, which trig ratio are we going to use? Kelsey? Sine. Sine is opposite hypotenuse. So now we set it up the same way. We write tangent of the angle, opposite over adjacent. Now we write sine of the angle equals opposite over hypotenuse. Sine of 35, sine of the angle, opposite side, hypotenuse. Now we have an equation with a variable in it. This says x divided by 14. How do we get x by itself? Multiply both sides by 14. So if we multiply the right side by 14, we get x. We multiply the left side by 14, we get 14 times sine 35. Now in our calculator, we punch this in exactly how it looks. No inverse sine, no inverse tangent, whatever. That's to find angle measures. Now we're just using the calculator and punching this in exactly how it looks. Now you need to be careful. Do 14 times sine of 35. If you do the sine of 35 first, your calculator starts to punch it in like this. Then you don't close the parentheses and you do 14 and then your calculator does some crazy junk. Okay? So punch it in exactly how that looks. 14 times sine 35. So that one you just punch in exactly how it looks. And there, that's your answer. Okay. You guys get 8.03? Yeah? All right, so that's our missing side. 8.03. 8.03. Yeah. Okay?
Wait, I'm still confused on like how you know which one.
It's in relationship to the angle. So Alice's question is like, how are we making sure which one of those to use? So you're figuring out what sides you have in relationship to the angle. Okay? So like, let's say we're trying to find y. If we're trying to find y, that's which side related to this? That's adjacent, and this is hypotenuse. So which one would be used? Cosine. Yeah, that's adjacent hypotenuse. All right, now, remember last unit how you guys had to learn all those special right triangles and use the angles and the ratios to find missing sides? Don't hate me. Don't hate me. Because how many people kind of like this? This is okay, right? Okay, how many people hated 30, 60, 90 triangle stuff and remembering all that? Oh, okay, not too many. I would say your tests say otherwise. All right, number 4. Sorry, no, just joking. I'm just joking. No, I'm not joking. I'm kind of joking. But look what you can do. Ready? This is 60 degrees. This is 9. We're still finding x. Now, those of you from last unit that remembered how to find the missing sides quickly, what is this? Bill a gun? It's 3 rad 3. I just heard a 3. This would be 3 rad 3. And this would be 6 rad 3. Well, guess what else you can use? Opposite adjacent, tangent of 60 degrees equals opposite
9/6.
over adjacent, 9 over x.
I mean, x.
In relationship to the angle, we're given the opposite side, trying to find the adjacent. Opposite adjacent. So now we need to solve for x. How do you solve this for x? Josh? What? No. If the 9 was in the denominator, you would multiply both sides by 9.
Divide by 9.
Divide what by 9?
Divide both sides by 9. Or more accurately, multiply it by 1.
No, yeah, because what ends up happening, so I'm going to put this over 1. Okay. What is this called now? From 2 units ago? A fraction equal to another fraction? A proportion, and you cross multiply. Right. So you do x times tangent 60 equals 9. 9 times 1 is 9. Now, how do you get x by itself? Divide, good. Divide both sides by, if it's x times tangent 60, divide both sides by tangent 60. And we're going to get x equals 9 divided by tangent of 60. Now, in our calculator, we can punch this in exactly how it looks. What's 9 divided by tangent 60? What? 5.2? Or 5.19, so approximately 5.2. What happens if we hit 3 square root of 3 and hit enter in our calculator? What do you get? That's what this side is, 3 rad 3 from last unit. What's 3 rad 3? Could somebody punch it in their calculator for us so we could have an aha moment and be done and be like, woo, geometry is so much fun? Same thing! 5.19, isn't that what we just said as well? Okay, so another way to find that missing side. Using trig. Okay, now which way is quicker? Memorizing the ratio? Yeah, see the thing with trigonometry though, like this has the ratios also. You want to memorize when there's a 35-degree angle? You want to memorize a 35, 90, 55 triangle? Just memorize all the ratios? Then you can write a book, like I told you about how we used to have back in the day when I was like 120, and we used to have the book to have to look all that stuff up instead of having a calculator. All right, I'm done. Did I talk too late too long? We gotta do some practice problems. What?
Actually use a book, or you just like
So before we had the calculator, there was a big book that had like, you would actually look up sine of 35 degrees, and it'll give you a decimal, like 0.2478. And then you would do 0.2478, then you would multiply by 14, and then you would go 0.2478 times 14, and that'd be like do your log division stuff.
So you have
Or
to
not, sorry, multiplication
do
stuff.
that every single time.
Yeah, in 1920.
Well, you're making
He's
it
not
sound
that
like you
old.
did that.
I know, I was making it sound like I did that. But I did.